course, today we're going to talk about word problems involving exponential function. Specifically, we're going to solve problems involving exponential growth and decay. So, we're going to start with exponential growth. Exponential growth is a pattern of data that shows greater increases with passing time, creating the curve of an exponential function. So we have here the formula in computing the exponential growth. So we have n is equal to n sub 0 times e raised to the power of k times t. Now remember, yung mga problems na i-discuss ko, we're going to use e as our base. So natural exponential function yung gagamitin natin. So we're going to use E as our base because most natural occurring phenomena growth continuously. So yung growth na minomodel natin dito is continuous. So these are natural occurrences such as populations, bacteria, radioactive decay, and etc. Now you are going to encounter problems about exponential growth in which they are not using A, but this time we're going to focus only with the continuous exponential growth or decay. So going back to our formula, we have n is the value at the time e. So ito yung kukunin natin na value given yung particular na time. N sub 0 is our initial value. Ito yung starting value natin. K is the rate of growth in which K is greater than 0. So, greater than 0 yung K natin kasi we are talking about exponential growth. Pero later on, pagdating natin sa exponential decay, magbabago naman yung K or rate natin. And of course, E is equal to 2.7182818 and so on. Now, you may use a scientific calculator in computing this problem, especially kasi may E tayo na value. So how are we going to use the formula? Of course, the first step is to identify the given, find the constant K, create an equation, and finally, solve the problem. So let's solve problem number 1. At the start of an experiment, there are 2,000 bacteria in a colony. In 2 hours, the population has tripled. Assume that the growth law n is equal to n sub 0 e raised to k times t applies. Determine the population 10 hours after the start of the experiment. So, it would be better if we're going to write first our given. So, yung n sub 0 natin or yung initial number of bacteria would be 2,000. At yung value naman ng t natin would be equal to 2. So, nakalagay dito, in 2 hours, the population has tripled. So, ibig sabihin, given na agad yung value ng n natin. So, from 2,000, it is tripled. So, 2,000 times 3, yung number of bacteria natin becomes 6,000. So, yung hahanapin natin dito would be, ilan kaya yung bacteria pag umabot na ng 10 hours. So, kung mapapansin natin, wala sa given yung value ng K. So, before natin ma-solve yung problem, kailangan muna nating kunin yung value ni K. So, to find K, substitute the given values and solve for the constant K. So, same pa rin yung gagamitin natin na formula. N is equal to N sub 0 times E raised to the power of K times T. So, substitute natin yung given. 6,000 is equal to 2,000 times E raised to the power of K times 2. So, given yung 2, which is our value ng t natin. So, simplify further, we can divide both sides by 2,000. So, yung 6,000 naging 3 at yung 2,000 naman naging 1. So, ito na yung simplified na form natin. 3 is equal to e raised to the power of 2k. Now, since yung k natin ay nasa exponent, then we're going to perform natural logarithm or itong ln. So we're going to have another video discussing how to solve natural logarithms. So we're going to perform the natural logarithm sa both sides ng equation. So ln times 3 or natural logarithm of 3 is equal to the natural logarithm of a raised to the power of 2 times k. So by definition sa logarithm natin, yung 2k, we're going to, or yung exponent natin, pwede natin siyang ilagay sa baba or as numerical coefficient ng natural logarithm natin. Okay, so yung 2k na exponent magiging 2k times Lm or natural logarithm of e. And also by definition, if we're going to get the natural logarithm of e, that would be equal to 1. So yung matitira na lang na sa right side ng equation natin would be 2k. Okay, pwede natin i-cancel itong ln e or yung natural logarithm of e since it is equal to 1. And to solve for k, we need to divide both sides by 2. Kaya yung value ng k natin would be equal to the natural logarithm of 3 divided by 2. Or approximately, it is equal to 0.5493. Now, since we have the value of k, we can use this to solve for the number of bacteria in 10 hours. So, para mas accurate pa rin yung magiging result natin, we're not going to use yet yung decimal na value. We're going to make use of yung expression na nakuha natin sa value ng k. So, again, k is equal to the natural logarithm of 3 all over 2. And n sub 0 is 2,000. So, we're going to substitute the given dun sa ating formula. So, in this case, hahanapin natin yung n. So, given yung initial na 2,000 at yung k natin which is ln 3 or natural logarithm of 3 over 2. This time, we're going to substitute 10 sa value ni t. So, this will be our equation now. So, how are we going to simplify this one? So, we're going to multiply first 10 by the natural logarithm of 3 over 2. And whatever the results, yun na yung magiging exponent natin sa e. So, e raised to the power of the product of these two expression. And after that one, we're going to multiply it to 2,000. So, the final answer is 486,000. Again, it would be convenient if we're going to use scientific calculator para mas madali nating ma-perform yung mga operations natin. Now, let's proceed with the second problem. The population of a city is defined by the function p is equal to 250,342 e raised to the power of 0.012 t, where t is equal to 0 represents the population in the year 2000. So, yung task natin is to find t when the population will be 320,000. So, in this case, yung missing natin would be the value of the time. So, since given na yung formula natin, we're going to make use of this formula and we're going to substitute yung mga given natin. Nakalagay na dito yung value ni P which is equal to 320,000. So, yung hahanapin na lang natin is yung value ni T. So, si T yung nawawala this time. So, we're going to divide both sides by 250,342. So, ito yung magiging result. Now, since yung result ng pag-divide ng 320,000 by 250,342 is decimal or magiging decimal, non-terminating decimal. So, it will be better na hindi muna natin siya gagalawin. So, to get the value of t, para mababa yung exponent natin na 0.012t, we're going to perform again natural logarithm. So, we're going to get the natural logarithm sa left side at sa right side ng equation natin. So, by definition, yung exponent natin na 0.012t would become or ilalagay natin dito sa baba as one of the factors. So, we're going to multiply the exponent by the natural logarithm of e. And we all know, same sa problem number 1, that the value of the natural logarithm of e is equal to 1. So, yung matitira na lang would be 0.012t. Okay, so we're going to divide both sides by 0.012t and using our scientific calculator, pwede natin siyang isolve. So, kukunin muna natin yung natural logarithm ng 320,000 divided by 250,342. After that one, kung nakuha na natin siya, we're going to divide it by 0.012. Finally, we get our final answer which is equal to 20.458 years. So, ibig sabihin, aabot ng 320,000 na population yung given na place natin after 20.458 years, or we can round it up to 21 years. So after 21 years, aabot na siya ng 320,000 na population. Next problem. A scientist starts with 100 bacteria in an experiment. After 5 days, she discovers that the population has grown to 350. Determine an equation for this bacteria population. So yung first problem natin, yung missing would be yung value ng K at yung value ng N. Yung second problem naman natin, yung missing is yung value ng T. This time, we're going to solve for our formula. What if yung formula yung nawawala? So, para ma-translate natin yung problem into a formula, of course, we are going to write first the given. N sub 0, or yung initial number of bacteria, is 100. Yung time natin would be 5 days. And after 5 days, we all know na dumami yung bacteria at naging 350. So, yung N natin would be equal to 350. So again, we need to solve first the value of our K. So using the formula, N is equal to N sub 0 times E raised to the power of K times T. We're going to substitute all the given. Then divide both sides by 100, kaya naging 3.5 na lang yung nasa left side natin. 3.5 is equal to E raised to the power of 5 times K. So since exponent na naman si K, we're going to perform the natural logarithm sa both side ng equations. So yung 5k, ilalagay natin as one of the factors. So we have 5k times the natural logarithm of e. And natural logarithm of e is equal to 1. So ang matitira na lang would be 5k. Kasi 5k times 1 is still 5k. So divide both sides by 5. Therefore, the value of our k is equal to 0.2506. Or we can have the expression or natural logarithm of 3.5 divided by 5. Now, since equation yung hinihingi, so we're going to substitute yung nakuha natin na value of k dun sa bagong equation natin. So, para pala makuha natin or ma-determine natin yung growth niya after 5 days, we need to use this formula. N is equal to 100 times E raised to the power of the natural logarithm of 3.5 divided by 5 times T. So, ito na yung given or ito na yung equation na hinihingi ng problem. So, kung mapapansin ninyo, sinubstitute lang natin yung value ng K at value ng initial number of bacteria natin. Now, how about exponential decay? So, the opposite of exponential growth is, of course, exponential decay. So, a quantity is subject to exponential decay if it decreases at a rate proportional to its current value. So, kung kanina, lumalaki yung number natin, this time, we have a decrease. So, same pa rin yung magiging formula natin. However, this case, k should be less than 0. So yung k would be a negative number. Now, how to use the formula? Of course, we're going to identify the given, find the constant k, create an equation, and finally solve the problem. So let's have problem number 1. The half-life of caffeine in your body is about 6 hours. If you had 1 cup of coffee 9 hours ago, how much is left in your system? Okay, so again, write the given. Yung initial natin na number of cup would be 1. At yung time natin would be equal to 6. And yung n natin would be 0.5. Now, bakit naging 0.5? 0.5 kasi we're talking about half-life. Pag sinabi nating half-life, we're going to determine kung ilang oras natin ma-reach yung half ng amount ng given value. So, ibig sabihin kung 1 yung given value, half of it would be 0.5. That is why, after writing the formula, yung values na sinubstitute natin would be n is equal to 0.5. Then, our initial value is 1 times e raised to the power of k times t. Ang t naman natin is 6 hours. So, same pa rin yung process to get the value of our k. So, yung 6k, we're going to place it here. and multiply it to the natural logarithm of e. So, since natural logarithm of e is equal to 1, therefore, ang matitira na lang is 6k. Divide both sides by 6. So, yung value ng k natin would be the natural logarithm of 0.5 over 6. Or we can express that one in decimals as negative 0.1155. Now, we're going to have or we're going to make use yung value of k natin to create our equation. So, nakalagay kasi sa problem that if you have 1 cup of coffee 9 hours ago, how much is left in your system? So, after 9 hours, ilan na lang daw yung natira na caffeine sa ating katawan o sa iyong katawan. So, we're going to make use of the value of k or yung derived na value ng k natin. And sub 0 or yung initial value is still 1. At ito na yung gagamitin natin na formula. So, yung formula natin ngayon would be n is equal to e raised to the power of ln or natural logarithm of 0.5 over 6 times t. Now, since we are looking for the value of caffeine in our body after 9 hours, so yung 9 isa-substitute natin sa value ng t natin or sa time. And solving it, the answer is n is equal to 0.354. This means that after 9 hours, the amount of caffeine in your system is 0.354 of the initial or original amount. Let's solve problem number 2. The half-life of carbon-14 is 5,730 years. If I have 10 grams of carbon-14 initially, express the amount of carbon-14 remaining as a function of time t in years. So, yung given natin would be n sub 0 or yung initial value natin is 10. So, we have 10 grams of carbon-14. And yung t naman natin would be 5,730 years. So, ibig sabihin, yung carbon-14, it will reach half-life after 5,730 years. So, since n sub 0 natin or yung initial value natin is 10, half of it after 5,730 years, it will become 5. Kaya yung n natin would be equal to 5. So again, we need to solve for the value of k. Substituting to our formula, we have 5 is equal to 10 times e raised to the power of k times 5,730. So, multiply natin yung k sa 5,730. It will become 5,730k. And, divide both sides by 10. So, yung 5 natin magiging 0.5. At yung 10 naman natin would be equal to 1. So, okay na hindi isulat si 1. Now, to solve for the value of k, we have to get the natural logarithm of the both sides of the equation. So, by definition, yung 5,730k natin, ilalagay natin sa baba as one of the factors. So, we have 5,730k times L and E. So, the natural logarithm of E, again, is equal to 1. So, what remains is 5,730k. Now, divide both sides by 5,730k. We will have negative 1.2 times 10 raised to the power of negative 4. Or pwede na rin ito na lang na expression para hindi tayo malito pag mag-substitute na tayo sa final answer or final formula. So using the value of k and the value of our initial number of carbon-14, we come up with this particular formula. So ito na yung equation na hinihingi ng problem. So we need to express the amount of carbon-14 remaining as a function of time in t years. Last problem, the half-life of uranium-235 is 703,800,000 years. How long will it take for 10% of a 1,000 gram sample of uranium-235 to decay? So, sisulat natin yung given. We're going to have 1,000 as our initial value. And yung half-life naman niya will take place after 8,000 years. And of course, yung n natin would be equal to 500. Kasi kalahati ng 1,000 would be 500. Now we're going to solve for k. Substitute natin yung given and divide both sides by 1,000. So yung nasa left side becomes 0.5. Then performing the same process, so we will come up with the value of k, which is equal to the natural logarithm of 0.5 over 703,800,000. So again, n sub 0 is equal to 1,000. So yung missing natin dito would be the value of t. We already have the value of k, yung e at saka yung initial. So bakit 900 yung nilagay natin dito na value ng n?
This is because the problem is asking about the time it will take for 10% of the uranium sample to decay. So since 10% of 1,000 is 100, this means that we need to find the time needed to decay 100 grams of the uranium sample. Ibig sabihin, 900 grams na lang yung matitira. Thus, we will set N to 900 and solve for T.
So aalamin natin kung gaano katagal na yung uranium-235 becomes 900. So we're going to substitute all the given sa ating formula. Divide both sides by 1,000, kaya naging 0.9 na lang yung nasa left side ng equation natin. Then, simplify further. We arrive with the value of t as the natural logarithm of 0.9 all over the natural logarithm of 0.5 over 703,800,000. So you can use your scientific calculator in computing this expression. So ibig sabihin, yung 1,000 gram na sample ng uranium-235 becomes 900 after 106,979,777 years. Again, this is just approximation kasi yung answer talaga natin ay may decimal point pa.
Now it's your turn. Try to answer the following questions. And that's a wrap. Please do not forget to like, share, and subscribe to my channel, Sir Ninyo. And you can also post your math problems in the comment section. And we will do our very best to provide solution to your questions. Because remember, every problem has a solution. At kung math ang problema ninyo, ako ang kaagapay ninyo, ako ang Sir Ninyo.